Now we're going to introduce determinants. So a determinant is a number that you calculate from a matrix. And for the moment, that's all it is. So it has lots of useful properties and relevance, but for the moment we'll just look at how to calculate a determinant from a matrix, and then we'll look at some properties of determinants. So, determinant of matrix A, written as det A, or A with two bars around it, for a 2 by 2 matrix is easy to calculate. The formula is given here. Let's say matrix A was equal to AB, CD. Then the determinant of A would be equal to AD minus BC. So for this matrix here, the determinant would be 1 times 4 minus 2 times 3. Right, is equal to 4 minus 6 is equal to minus 2. Calculating the determinant of a 3 by 3 matrix is a little bit more complicated. So here is a formula for calculating the determinant of a 3 by 3 matrix, and it involves taking the elements across the top row and then calculating determinants from smaller matrices that are made up out of the 3 by 3 matrix. So using this formula is known as the expansion of the determinant along the first row. So I'll do this once, and then we'll discuss how we got that formula and other ways of calculating a determinant for a 3 by 3 matrix. So take this one. Right, following the formula, the determinant of A is equal to, so we have A11, which is 1. There's A11 times the determinant of this matrix. So that's the matrix that's left when you take out the row and column of A11. Then we have minus A12. There's A12. First row, second column. That's minus 2 times the determinant of what's left when we take that row and column out. Minus or plus A13. There's A13. So it's 4 times the determinant of minus 1, 0, 3, 1. Again, that's what's left when I took out row 1, column 3. So that's equal to 1 times 0 plus 3, following that 2 by 2 formula above for the determinant. Remember that each of these is the determinant of a matrix. Minus 2 times this determinant, which is minus 1 times 2 plus 3 times 3, plus 4 times minus 1 times 1 plus 0. 3 times 0, it's going to be 0. So that gives me 3 minus 2 times minus 2 plus 9 plus 4 times minus 1, which gives me 3 minus 2 times 7 minus 4 is equal to 3 minus 14 minus 4, which gives minus 18 plus 3 is minus 15. So that's an example of calculating a determinant for a 3 by 3 matrix. So we saw there that we were deleting rows and columns, and we were being left with the determinant of a smaller matrix. So that remaining determinant is what's called the minor. You might also have noticed that the first term was positive and then it was minus, and then the third term was positive again. So the sign associated with it, the minor, is given in this array here. So if you're going across the first row, it's going to be plus, minus, plus. If you were doing the second row, it would be minus, plus, minus. So we say here that the minor multiplied by the appropriate sign is called the cofactor big Aij of the element Aij. So to calculate the determinant, you would go across a row or down a column, and you'd multiply each element as you go times its appropriate cofactor. And the cofactor is whatever the appropriate sign of the element that you're on times the determinant of the matrix that's left if you remove that row and column. Now that all seems a bit complicated, but when we do a few examples, it's not that hard. In the last example, we went across the top row of the matrix, so that was first row, first column, first row, second column, and okay, that's actually a typo. That should be A13. That should be A13. First row and third column. So these big A's here are their respective cofactors, which are what you multiply them by. The cofactor is the minor times the appropriate sign. So that's why we got plus, minus, plus. That is from this little diagram here. So that's why this one is plus, this one is minus, and this one is plus. And then these m's, these are the minors. So these are determinants. And it's the determinant of the matrix that's left when you take out the relevant row and column from the big matrix. So let's go through this example. We're given a matrix here, A, and we're asked to calculate the determinant by evaluating the minors and cofactors associated with the first row and then with the first column. So, first thing we'll do, going across the first row, it's going to be 1, 1, 1, 2, and 1, 3. So first we calculate the appropriate minors. So M11 first. So we delete row 1, or column 1, and row 1. And we're left with this matrix. So M11 is the determinant of minus 4, 2, minus 1, 1, which is equal to minus 4 times 1 minus minus 1 times 2, right, which is equal to minus 4 plus 2 equals minus 2. So that's M11 minus 2. M12, here is element 1, 2, so we delete that column and that row, and we want to calculate the determinant of 6, 2, 2, 1, which is equal to 6 minus 4 equals 2. So M12 is 2. Next, we do M13. So here is position 1, 3, first row, third column. Delete that row and column and get the determinant of what's left. 6 minus 4, 2 minus 1. The determinant is 6 times minus 1 minus minus 4 times 2 is equal to minus 6 plus 8 is equal to 2. So I'm going to put A back in here so we can have a look at it. And then we calculate the determinant expanded along the first row. So that's going to be 3 times m11 minus 4 times m12 plus 5 times m13. So that's equal to 3 times minus 2 minus 4 times 2 plus 5 times 2 is equal to minus 6 minus 8 plus 10 is equal to minus 4. So that's the determinant. Try the second part yourselves, going, instead of across the first row, go down the first column. You should get the same answer, and then try exercises A, B and C here.